The person who wakes up tomorrow is not you. Not exactly. And by the end of this video, you won't be able to unsee what sleep is actually doing to your brain every single night. Most people think sleep is passive. Your brain gets tired, shuts off, starts back up, like a phone plugged in overnight. That image is wrong in almost every way. Your brain during sleep is more active than during most of your waking hours. And what it's doing while you're completely unconscious is some of the strangest work it does all day. So let's go through it piece by piece, because each part is weirder than the last, and the last one changes how you think about every morning you've ever had. Let's start with something almost nobody has heard. While you're asleep, your brain replays memories from the day. Most people know that part. What they don't know is that it sometimes replays them backwards, literally in reverse order. Scientists watching brain activity during sleep found the hippocampus, the part of your brain that handles memory, firing sequences of neurons in the opposite direction from how they originally fired when the memory was first created. Think about what that actually means. If you learned a route somewhere today, your brain doesn't just replay it again from start to finish. It runs it from the end back to the beginning, arrival point back to where you started. It's the same if you had an awkward conversation or made a decision that didn't go well. The brain doesn't just replay those moments chronologically. It starts from the outcome and rewinds through every step that produced it. The theory is that the brain is running a backwards audit, not replaying the day for fun, analysing it in reverse to understand how you got to each outcome, what worked, what didn't, what you might handle differently next time. Your sleeping brain is essentially doing a post-game review of your own choices every single night, without asking for your input and without letting you watch it happen. But before we get to what the brain does with those memories, there's something more physical happening first. Something concrete and visible. And it's the thing that makes everything else in this video possible. When you fall asleep, your brain cells physically shrink by around 60%. Not the whole brain. The individual cells themselves get smaller. And what that does is open up the gaps between neurons, gaps that are normally too tight for much fluid to move through. Once those gaps open, fluid floods in and washes through your brain tissue, carrying out the waste products that built up during your waking hours. Toxic proteins, byproducts of thinking and processing, including the specific protein that accumulates in the brains of people who develop Alzheimer's disease. Your brain cannot clean itself while you're awake. The cells are too tightly packed. Sleep is the only window where the physical structure of your brain opens up enough to let the flush happen at full scale. Every night you don't sleep deeply enough, that waste stays a little longer than it should. Here's where it gets personal. Common sleeping pills, the ones millions of people take every night assuming they're doing their brain a favour, block this cleaning process. Researchers found that zolpidem, the active ingredient in Ambien, disrupts the specific blood vessel rhythms that drive the fluid through the brain. You lose consciousness. But the cleaning system doesn't activate properly. You pass out. The fluid doesn't flush. The waste stays right where it was. Which is exactly why people take a sleeping pill, sleep 8 hours, and still wake up foggy and slow with no explanation. You were unconscious. Your brain was not actually serviced. There's a difference between being asleep and being cleaned, and most sleeping pills only guarantee the first one. Now, the physical cleaning is striking, but it's almost the straightforward part. Here's the thing about sleep that most people have completely backwards. Most assume sleep is when the brain saves memories. And it does save some, but sleep is also when your brain actively destroys connections. A large chunk of them. While you were awake today, every experience, every skill you practiced, every conversation caused your neurons to build new connections to each other. Thousands of them. And during sleep, the brain quietly takes most of those apart, on purpose. It evaluates every new connection it built, keeps the ones that fired strongly enough and often enough to matter, and removes the rest. The weak ones, the redundant ones, the noise. Think about the last time you tried to remember something from a few weeks ago and it was just gone. Not faded, gone. That's not a failure of memory. That's the system working exactly as designed. Your brain decided that piece of information wasn't worth the space and removed the connection during sleep. You never got a vote on it. Nobody asked you. The editing happened, and by the time you noticed the memory was missing, the decision was long since made. What you wake up with is not everything you experienced. It's a curated version, assembled by a process that runs without your input, finishes before you open your eyes, and never shows you what got cut. Now here's the part most people get wrong about sleep deprivation. They think missing sleep means the brain falls behind on one thing, but sleep actually does two completely separate jobs, and they fail in completely different ways when sleep doesn't happen. The first job is the cleaning we just talked about, waste removal, fluid flushing through shrunken cells. When you don't sleep, the brain actually tries to compensate for this during the day. It fires small emergency cleaning bursts while you're still awake, and every single time one fires, your attention cuts out for a few seconds. That thing you call zoning out, losing your train of thought mid-sentence, rereading the same line 4 times, going completely blank in a meeting for no obvious reason, that's not you being bad at focusing. That's your brain briefly going offline to run emergency waste removal it didn't finish the night before. Sleep deprivation doesn't just make you tired. It turns your waking hours into a patchwork of tiny blackouts that you don't even notice as they happen, because by the time you're aware something cut out, your brain is already pretending it didn't. The second job is the connection editing, and that one has no emergency version, no daytime workaround, no way to catch up later. If you don't sleep deeply enough, the editing simply doesn't run. You wake up with a cluttered, unprocessed version of what you learned. Not because the memories were weak, because the brain never got to finish deciding what to do with them. Caffeine can temporarily paper over the first problem. Nothing touches the second one. And then scientists found something that made this whole picture stranger. The memories that survive the editing process don't just stay where they started. Short-term memories that formed in the hippocampus during the day get physically moved during sleep to a different region of the brain for long-term storage. It's not a copy that gets made. The actual representation moves. The version of a memory you pull up a week from now lives in a completely different location than it did the night it was created. Sleep is the moving truck. Without it, memories pile up in temporary storage and get overwritten by whatever arrives next. This is why cramming the night before a test works worse than sleeping on what you learned. The knowledge is there. It just never got filed properly. It's sitting on a desk that's about to be cleared for the morning. But here's where it crosses into something unsettling. Researchers paired a specific sound with a specific memory while people were awake, basically training the brain to link the two. Then, while the subject slept that night, that sound was quietly played through a speaker in the room. The brain, hearing it during sleep, automatically replayed that exact memory more than anything else from the day. Subjects woke up remembering it better than everything else they'd experienced. No extra studying, no drug, just a sound played in a dark room while someone was completely unconscious. Your overnight editing process can be directed from outside, while you have no ability to object or even notice. Someone with access to your bedroom and knowledge of what you experienced during the day could, in theory, shift which memories survive the night and which ones get quietly removed. That's not science fiction. That's a published, peer-reviewed study. And nobody is talking about it. Most people have a question they've never found a clean answer to. Why do some days feel sharp no matter how much you slept, and other days feel slow no matter how many hours you got? The answer has nothing to do with how long you were unconscious. During sleep, the brain resets to what researchers call criticality, a precise internal balance where it processes information at peak efficiency. Being awake pushes it out of that balance. Every hour of thinking and reacting moves the system further from the state where it works best. Sleep is the only thing that pulls it back. Caffeine doesn't do this. caffeine makes you feel less off balance. It doesn't restore the balance itself. 9 hours of shallow sleep won't reset it properly. 6 hours of deep sleep might. The number of hours isn't the whole story. What matters is whether the deeper stages of sleep actually ran. And the way to know if they did is what happens next. And here's the detail that makes all of it click into place. During deep sleep, your brain produces tiny bursts of electrical activity called sleep spindles. Each one lasts less than a second. Hundreds of them fire every single night while you're completely unconscious. These are the moments when the brain is actively deciding what to keep. Scientists measured them directly. The more spindles a person produced in a single night, the better their memory tested the next morning. Not slightly better, measurably, consistently better. Fewer spindles, more forgotten. More spindles, sharper the next day. Which means the mental sharpness you feel on any given day partly comes down to how many of these invisible electrical sparks fired in your brain while you had no awareness of anything at all. Not your diet. Not how motivated you feel. Not how many hours you logged. Tiny sparks you will never feel, never remember, and have almost no direct control over. Firing in the dark. Deciding who you are when you wake up. So here's what sleep actually is. It's your brain running your day backwards to audit your decisions. It's your cells shrinking so the structure of your brain can open up and flush itself clean. It's the quiet removal of most of what you built during the day, with no input from you. It's memories being relocated to different addresses inside your skull. It's hundreds of invisible sparks deciding which version of today gets to become part of who you are. Here's the part nobody actually says out loud. You have never met the version of yourself that exists right before sleep. By the time you're awake enough to reflect on what happened yesterday, the editing is already done. The connections are already cut. The memory's already filed or discarded. The only version of yourself you ever get to meet is the morning version. The one that already had things removed. The one the brain already decided on. Which means, in a very literal, mechanical sense, sleep isn't just something that happens to you, it's something that produces you every single morning. Watch the next video, because what happens during the dreaming part of all of this is even harder to explain.